The subject that we're going to learn in this semester for computers is basic computers and information sciences, and the code for this subject is BMLS 1002 or BPHY 1006, depending on the department. And we are going to learn about the basics of computers in this. And by basics, I mean that the introduction of how computers are useful and how computers are being used in your area, and how the data has been manipulated or managed using the computers. Okay, so in this particular lecture, we are going to talk about the basic of computers, like what are the parts of computers, and what are the characteristics of computers, what are the application areas in which computers are being used. So to start with, we need to understand what is a computer, and what is the definition of computer. And when we say computers are, when we talk about a machine that is used for manipulations for of data, a machine that is used for calculations of arithmetic operators, operations, and logical operations. When we club everything together, it forms a machine. It creates a machine that is known as a computer. So we have these, depending on the way we are using computers. The definition of computers is defined in these three ways. That one is, a computer is a machine that manipulates data according to the list of instructions, and instructions are basically the set of the code that we give to the computer, on basis of which the data that we enter is being manipulated and being processed, and according to that processed data we get the output. Okay, so a computer, another definition says, a computer is a device that is capable of performing computations and making logical decisions at the speed of millions and even billions of times faster as that of a human being. Okay, so when we compare a computer with a human being, we need to understand the computer is a machine that can perform ample number of instructions, that can run ample number of instructions and operations at a very high speed. And a computer is a device that is actually capable of performing computations that are even very much complicated or complex as compared to what humans can do. Okay, so the third definition says that a computer is an electronic machine which is used for data processing. The data is being manipulated and processed, and the output which comes after the processing of data is known as the information. The raw data that is provided as input to the system is being processed and is being manipulated. It is being worked on by the processor, and then the result that comes out through an output device is known as the output. And the output in the form of, when we say the output is the information that we get from the computer. Okay, so in simple terms, we can say that a computer is a machine that is used to get the desired output. Whatever we want to get as an output, that this computer as a machine performs that work on the data we provide according to the instructions we provide. Okay, and then it gives the result, and that result is the desired result, the desired output that we want a computer to give us. Okay, so whatever task that we want to do, writing, documentation, typing, or painting, or calculations, or even communications, right? So everything that we come along nowadays is all done by computers, and it has been made very easy by the computers. Okay, now the computer can be divided into two main categories: the hardware and the software. So hardware is basically something that we can actually touch with our fingers, and through which we actually work on the computer is the hardware, right? When we want to give some instructions or type something, we use a keyboard. When we want to get some output, when we want to receive some data from the computer, we use a output device as a printer or a monitor. Okay, so all those input devices and output devices that we can touch and through which we interact with the processor is known as the hardware. And in a processor also, when we talk about the hardware, is the physical part. For example, we have these chips that are comprised, the motherboard that we have, the hard disk that we have, all these things that are there in the system that are used to interact with the software is known as the hardware that we can actually touch, and that build the computer is known as the hardware. Okay, and what is a software? For a computer hardware to work, it must be, it must follow some set of instructions, and these set of instructions that are provided, that are supplied, are known as the software. We'll talk about these things in details in some time. So, examples of hardware, the hardware is basically refers to the computer's physical components, and those physical components are, for example, we have this computer case, we have CPU, that is a central processing unit. We're not talking about the processing unit as a software. We are referring to the processing unit as a hardware, that is the platinum chip we have, whatever devices that are incorporated to make it a computer are known as the hardwares. And then we have monitor that is used to get the output. Then we have keyboard and mouse that are used to get the input, disk drives, zip drive, CD-ROM, DVD. These all are the storage devices, that are secondary storage devices that are connected to the system. Then we have the hard drive, that again is a storage device, memory, RAM, storage used for storage. Then we have speakers that are used as the output device, and printer as the output device. Speakers are basically used for getting the audio output, and the printers are used for the hard copy or the hard output. Okay, so these are all the hardware part that are used for basically manipulating or using the softwares that are provided. Then we have the softwares. The term software basically refers to the set of instructions that directs the hardware to accomplish a task. That means that whenever we have a hardware to interact with, we need some set of instructions that provide the instructions to the hardware to perform a task. Okay, so these softwares are basically of three types. One is your system software, another one is application software, and third one is utility software. So whenever we say we have a software, itself is some, a single instruction, is a code that we provide, a single instruction. When we club some set of instructions together, it forms a code. When we club some code together, it makes a program. And when we include some certain programs together, it is known as a software. So basically a software has ample number of instructions inside it, and a software has multiple programs running that are interconnected, or they're interlinked somehow to create a software. Okay, so when we divide the softwares in the types like system software, application software, and utility software, every software that we have has a specific task to accomplish, right? So depending on that task, we have these categories of softwares, and to understand these categories, we have the system software. The system software is also known as operating system. And why it is known as operating system? Because it actually controls all the components of the computer, and it serves as an interface between the user and the hardware. Okay, so whenever we have some these all these application softwares, they actually run on the system software. So the system softwares are used to control all the components that we have on computer, and it actually it gives the a platform for the different types of softwares to actually run on and to work on. The examples of a system software, one main example is the operating system, but other than that we have the clock that we have, that all that we do not actually put in explicitly. Whenever, suppose we have an application software, we have to put those application softwares explicitly for completing a task. But the system softwares, we do not put explicitly, they're already there in the computers, and these system software serves as the base of the computer to actually run other applications and other softwares on the computer. Okay, so when we say examples of system software, we have many examples of system software. For example, we have this clock, calendar that we have. Then we have these some of the games are there that are already there in the system, and many other softwares that are basically lets other applications to run on, or it provides an interface between the programmer, between the user and the hardware, that is known as a system software or operating system. And we the one more thing that is very important to understand, that we do not want any kind of manipulations or changes to the operating system or the system software, as any change to the system software can actually change multiple things, and it can damage certain things if changed unknowingly. So we keep the operating system, or we keep the system softwares in read-only memory, and not where they cannot be very much easy to access to the other users or people who are not really who don't know about that particular system that is being managed. So system softwares are basically kept in ROM. And next is we have this application software. Application softwares are used to design, they are used or designed for a specific purpose of the users. This is like, for example, if you are going to do some certain task, and for that particular task, we need to have some specific software that is used for accomplish that task. For example, we have this for accessing some for not for accessing some Word document. Suppose if we are going to do some documentation, we need to have MS Word. For doing this, suppose we have to make a presentation, we need to have MS PowerPoint. Similarly, for different types of tasks to perform on systems, we have different application softwares. Like suppose we do not want a document to be changed later, so we have to have this Acrobat Reader. Then we have this other softwares. There are many softwares, many gaming softwares that are there to that are downloaded on the systems, or that are they're put explicitly on the systems for performance of to get to get the specific application out. And for the some of the main examples of these application softwares are Acrobat Reader. We have this MS Office that is there. MS Office has multiple softwares that are used, and then we have other softwares that can be downloaded and that can be used to manipulate the information, or to get the desired output according to what is required by the user. Okay, so basically application softwares are explicitly put, and they are used to manipulate the data according to the user's usage requirement. Okay, so these are the applications. So that was the application software. Now moving on to the utility softwares. Utility software is basically used to remove, or to do a specific task for the computer, to use a complex situation, to remove a complex situation, to remove a problem that comes into the computer. And suppose we have a situation where we have unnecessary bugs in the system, when we have unnecessary intruders in the system that are going to take some data, or when we are suppose we have some kind of crash in the system, and we need need some sort of recovery of the data. We need to have some backup of the data. For that particular purpose, we have the utility softwares. And the examples of the utility softwares are the system so security softwares that are there. Then we have partition magic, then we have backup utility, data recovery, Ghost, antivirus. These are all of these are the examples of the utility softwares, and every utility software is put into the system for a specific task. For example, if you want to have some data retrieved, we need to have the data recovery software. If you want to we have to safeguard our system from some virus, we need to have an antivirus. And suppose we need to have some malware in the systems, we need to have that support to save the system from any kind of intruders or malwares, right? So or when we want to partition for the drives, magic partition can be used. So all these softwares that are there that are used for a specific purpose, for maintaining the system, for the system basically maintenance of the system, and to remove if there is a problem in the system or to solve a complex situation in the computer, we use the utility softwares. Okay, so moving on to the next thing. Uh, Whenever we talk about a computer, we need to understand that whatever system a computer is working on is the input. Whatever information we provide to the system or the data that we provide to the system is known as the input. And then the computer, it performs some processing task on that particular input and gives you the expected results. Okay, like for example, in humans, suppose I have some exam. What would I do? I will try and remember things. I'll read stuff. In real life, if I say, not particularly for an exam, suppose I have a situation where I am learning throughout the phase, right? We keep on learning, we keep on doing things that puts information in our brain, and according to the processing of the brain, according to what our processing is done on this on the information that we have gathered, we revert back, we give the expressions, we give the output to the word, right? So this is how your system also works, that it according to the input you provide and according to the instructions you provide. Input and instructions, both things matter equally. So according to the input you provide and according to the instructions that we give, or that are basically used for doing the processing on the input, we give the desired output. Or if the output is not as we desired, or if the output is not correct according to what we needed, then it has to be a human error, because machine won't make a mistake according to the instructions. If we're not giving the instructions properly, then we might not have the accurate output. But if we are providing the right instructions and the right input, we're going to get the expected and the right output. Okay. So the information process cycle, we have these four stages where the information processing is done, and the four stages are basically input providing stage, second is the processing stage, third is the output stage, and fourth is the storage. We are already slightly familiar with the input processing and the output, but what is storage? Storage is basically when we are processing in a huge amount of data, we need to have a storage where we can save the output that we're getting. Otherwise, if you're simply giving the input, doing the processing and getting the output, it is not necessary every time if the output is very small or it is required for a very short time. But if we have output that is huge and that is required at a later stage, we need to have storage, and for that purpose storage is there in the information processing cycle. Okay. Other than this, next thing that we have, this is all computer is about. Next thing is the that we're going to learn today is the characteristics of computer. A computer is basically a machine that has ample number of characteristics, and all these characteristics that are there, they are the base of computers that actually make it such a popular device to use. Okay, so when we talk about characteristics, to name them, we have these uh, 7 characteristics that I've named here. But okay, I'll just read out the names to you. Memory, that is the storage. Then we have automation, reliability, versatility, then diligence, and then accuracy and speed. Okay, all these characteristics, they together form a computer, and computer is such a thing that is being used like in everywhere nowadays. So these are the main characteristics that actually make it so much popular and so much available in different forms in different areas of the of in our real life. Okay, so, starting with the very first characteristic that we have for computers, that is speed. Speed of a computer, may be defined as the time taken by a computer to perform a task. Okay, so whenever we say the whole, this when we talk about the speed of a computer, we all know that the speed is of a computer is very high, and in the earlier stages, in the earlier generations of computers, the speed used to be very slow as compared to what we have now. And the speed is basically calculated as a whole process. Whenever we provide an input, the processing is the time that a computer takes in performing a task, or processing a process, working on a process, is the speed, right? So it takes a few seconds for a calculation to that we take hours to solve, right? When we talk about computer speed, as humans, we know that we take too much time as compared to what a computer is, as compared to what a computer can will take to perform a task. Okay, and it works in fractions of seconds, and most of the computers work on in micro or nanoseconds, or in the time that humans take is way longer than as compared to what a computer takes. Okay, and the speed is basically measured in terms of megahertz and gigahertz. These are the two ways in which we are going to measure the speed of computers. uh, you must have heard in terms of how fast the system works. Totally depends on how much memory as a RAM it has. That we'll talk later. But basically, it is measured in terms of megahertz and gigahertz, the speed. Now, these are some of the units of speed. That is milliseconds, that is 1,000th, and then we have microsecond, that is 1 millionth. Then nanoseconds are 1 billionth, and one picosecond is 1 trillionth. And nowadays, what type of systems what we are using, what computers we are using are actually working at a speed of 1 trillionth of a second. Okay, so this is one major characteristic of a computer that makes it such a popular device to use. Okay, so next thing is accuracy. The accuracy basically is the correctness of a system, and we all know that whenever we talk about computer, the accuracy is a 100%. Why we say a computer is a 100% right? Because until and unless you are providing the right input, you're not going to get the right output. And if you are providing the right input and the right set of instructions, you're always going to get the right output. Okay, so accuracy, I'll just read this from here, that the condition or the quality of being true, correct, or exact, and freedom from error and defect, any kind of defect that could be there, precision or exactness or correctness. All these words can be used for accuracy, and the computer actually is a device that is accurate in all these terms. It is always true, it is always correct, it is always exact. The output is always exact, what we ask for, if you're providing the right input and the right set of instructions. And then we have we do not have any kind of error or defect, or The precision means basically the exactness, the how exact is the output. The expected output has to be absolutely same. The output has to be exactly same or as the expected output. Then we have the correctness, that the system is going to give you is always going to give you the correct output. Okay, and the computers are the accurate machines that can perform large number of tasks without any errors. But if we are feeding a wrong data to the computer, then it is going to give you the wrong output. It doesn't matter how many times you try. If you're not giving the right input, you're not going to get the right output. So if you feed the wrong data to the computer, it is going to return the same wrong information, that is called GIGO, that is garbage in, garbage out. Okay, this is one term that we use, that if you provide garbage to the system, it is going to give you garbage. It is not going to give you the right answers. Okay, and the errors in the computers are due to humans and inaccuracy of the humans. It is never that the system is inaccurate. It is always the degree of inaccuracy of the system is only that only depends on the inaccuracy of a human being. Okay. Uh, this is accuracy, and next is diligence. Diligence is basically tiredness. If you are providing input to the system, that a set of instruction that you're providing to the system is being done, say 15 times, 20 times, or maybe 1,000 times or 5,000 times, a system never gets bored. It never gets tired. Okay, so basically, by the word diligence, we understand that the capacity of a computer of performing repetitive tasks without getting tired, or is known as diligence. Okay, and the computer is free from tiredness or lack of concentration or monotony or fatigue. Yes, all these words are basically used interchangeably for basically tiredness, or what humans actually feel if you have to if you have to perform a task, say 15 times or even 10 times or even 5 times, you get bored of it, right? You lack concentration if you're bored. You feel monotony, you feel fatigue if you are doing the task again and again. But computers, in terms of computers, it is never there. If a computer is doing a task, say 100 number of times, it is not going to get bored ever. Okay, so if even if the millions of calculations are being performed, a computer will perform every calculation with the same accuracy without any change in the output. Okay, and then we have this versatility. Versatility means that performing multiple types of jobs. As we all know that we have different software, we have different, when we're talking about application softwares, then we talked about that according to the type of job that you want to a system to perform, you have to provide the type of software. And that is why we say the capacity of a computer of performing more than one task is known as the versatility, right? And versatility means the capacity to perform different tasks and the different types of work completely without getting bored, and having exact accuracy of the output that it is going to give. It is not there that if one type of task is performed very well, the other might not be. So it is not there. Every time you provide any type of task, you give to the system, it is going to perform every types of task. We have multiple types in which we can have the system, we can use the system. Okay, and one moment a computer is preparing a result for a particular examination, next moment it could be preparing an electricity bill, next time could be keeping a record of hospital patients, and then the next it could be creating the banking documents, right? So every type of task that you have for a computer, it can perform, and it can give you the desired output without considering that it has to do a particular task or it has to perform a particular task. Okay, so the next characteristic of a computer is to remember stuff. It has a huge storage. It can store as much data as you want. Okay, unlike humans, when we talk about human beings, we have a limited storage, and if suppose we do not have we are not refreshed with the data, we are not brought that data to us again and again, we keep on forgetting the data, right? We get keep on forgetting things, right? But when we talk about computers, it never forgets. We have a huge storage in which we can store data. And for example, when we click pictures, we save pictures, videos from like a huge amount of time back, and we use and we revive all those things by actually going through the data again, right? So basically computer has a huge storage, and the action or the methods of storing something for the future use is basically the power of remembering, right? So human beings, they are when something is not really important to them, they tend to forget it, and they tend to keep it in the back of their minds, and then they forget that thing. If it is not important, they gradually forget it. But for computers, if you have stored something, so if you have stored some information for a particular time, it remains there until unless you explicitly delete that information and you explicitly free that storage from that information. It is going to be there forever, and the computer can store and recall any amount of information because it's a secondary storage capability. Because when we are going to talk about primary storage and secondary storage later, but when we talk about huge amount of storage, it has to be the secondary storage that is there with the computer, in which it stores all the data that is there. Okay, so and we can recall all that information with the same accuracy, with the same data will be provided after many years of storing that information, and that we are going to receive the exact data that was fed to the computer, and it never loses or forgets the data until and unless an explicitly deletion of data is taken place through some other user or some other person. And the storage capacity of a computer can be measured in terms of kilobyte, megabyte, gigabyte, and terabyte. Earlier, we used to have systems in which we used to have a little less data, a little, and even the kilobyte were used to be very costly. But now, as the time as we have grown through the generations of computers, now the storage has become much easily available and much cheaper as compared to what we used to have. So the data that we have is basically is having, we have kilobytes of data. We used to have kilobytes, now we have megabytes, gigabytes, and terabytes depending on the storage that we require. And then we have this intelligence quotient, and the this is basically known as the ability to comprehend and to understand the instructions that are performed at the tremendous speed and with the exact accuracy. And the One second. So, when we talk about a computer as a machine, it has no intelligence of its own, but depending on the intelligence that is provided explicitly by a programmer to the machine, it can actually perform as intelligent a task as a human being, right? So basically, we have to train the machine. We have to train a system to get the exact output that we are expecting at a later stage. But and through the development throughout the years that we have, and we have artificial intelligence in computers nowadays, and the programmer, when we're trying to get the information, when we're trying to get the data as an intelligent machine, when we're expecting some a computer to give the output as we are expecting, we have to train that system. We have to tell that system explicitly that this is what is expected next time you are asked. We have various learning learning processes for the computers in which they can learn, and we can make them learn. We have machine learning or artificial intelligence through which we can train the system to perform intelligently and at a later stage. Okay, and these are some of the examples that we have. The games like chess, they can be played through computers. And how we can play a game that is there in the computer. How can we play a game with the computer? Because we are explicitly providing that intelligence to the system to get the desired step or to get the desired output, right? So, and how is it possible for a machine without mind to think and to give you the output? Because we are telling that machine that in case of suppose when in case of chess game, suppose, so we are going to tell the machine, if this is the setup, this is the possible input that you're going to give at this particular setup. You have to play the game accordingly. We are going to have a certain steps that are defined, and the machine can choose and do the task that is required to be done at the depending on the setup we have, right? And to that is made possible by the programmers. The robots are made for a different task, and the softwares are made due to which the machine can talk to us. And the example of this kind of machine, or the intelligent question that we have added to the system, the very recent example that we have is for Alexa. If you have heard, like Alexa as a device has been made and has been used in many homes now, and it was made by Amazon. And the task that you ask Alexa to perform, the task that you ask any of these kind of machines that are being made now to perform, they're going to perform accordingly, right? So this is basically possible only when the programmers are training the machines to perform accordingly. Okay, and okay, so this is it for today. In the next class, we are going to learn about the application areas of computers, and we are going to move further with the information that we have for computers. And for now, the lecture is over. And if you have any queries, you can come to me and you can ask me anytime.